Assalamualaikum and hi everyone. Today we are going to learn about chapter 7, which is Ionic Equilibria. In this chapter, it is divided into 3 subtopics. Today we are going to learn about 7.1, which is on acids and bases. Here are the learning outcomes. At the end of this lesson, students should be able to A. Define acid and base according to Arrhenius and Bronsted-Lowry theories. B. Identify conjugate acid and conjugate base according to Bronsted-Lowry theory. So keep your head up and let's start. What is an acid? What is a base? Today we are going to look through the definition of acid and base based on Arrhenius and Bronsted-Lowry theory. Arrhenius acid and base. According to Arrhenius, acid is a substance that has hydrogen H in its formula and dissociates in water to produce H plus ions or H3O plus ions. For example, we have HNO3 and look at its chemical formula. There is hydrogen in its chemical formula. So when dissociates in water, this substance is going to produce H plus ions and NO3 minus ions. Therefore, HNO3, which is also known as a nitric acid, becomes an acid because it dissociates in water to produce H plus. Next, we move on to the next example. We have CH3COOH and it has hydrogen in its chemical formula. It's going to dissociate or react with water to produce CH3COO- ions and also H3O plus ions. So based on these two examples, we can see that both of these substances dissociate in water to produce H plus ions and also H3O plus ions. That make those substances become acid. Next, Arrhenius base is a substance that has OH in its formula and dissociates in water to produce OH-. For example, given NaOH, so we can clearly see that it consists of OH. Therefore, when it dissociates in water, this compound is going to produce Na plus and also OH minus ions. So that makes NaOH, which is also known as sodium hydroxide, as a base. Remember, based on Arrhenius theory, acid produce H plus or H3O plus ions. Meanwhile, base produce OH minus ions. Next, we move on to Bronsted-Lowry acid-base theory. This definition focuses on products and reactants. Remember, focus on the product and reactants because both correlate to each other. According to Bronsted-Lowry, acid is any species that donates H plus or considered as a proton donor. So in order for that species to donate H plus, it must consist H hydrogen in its formula. For example, we have ethanoic acid. Okay, so ethanoic acid, CH3COOH, consists of H in the formula. Therefore, it's going to donate its hydrogen, forming CH3COO- and also H3O plus ions. So that makes CH3COOH as an acid because it donates its proton. And that makes CH3COO- as a base. It's conjugate base. So when CH3COOH is considered as an acid, therefore another reactant, which is H2O, will be the base, and the product of H2O will be the conjugate acid. Next, base is any species that accepts H+, or known as proton acceptor. For example, we have this equation. So we have NH3 plus H2O. So both consist of hydrogen in the formula. So it's hard to tell by just looking at the reactants. So now let's look at the product. So we have NH4 plus and also OH minus. So focusing on this species, NH4 plus, that means NH3 has an extra H plus. So that means NH3 accept proton. So that makes NH3 as a base, right? Therefore, its product is going to be the conjugate acid. Meanwhile, water will be the acid and OH minus will be the conjugate base. Remember, according to Bronsted-Lowry theory, acid is the proton donor, meanwhile base is the proton acceptor. In this chapter, we need to focus on the base conjugate acid pair. For example, we have this equation. So, by looking at the reactants, okay, we can see that this species consists of hydrogen. Meanwhile, another reactant don't have any hydrogen bonded to it. Therefore, this will be CH3COOH will be the acid and its product will be the conjugate base. Okay, it is considered as acid because it donates its proton. Next, Cn minus, which is another reactant, will be the base, and HCN, its product, will be the conjugate acid. It is considered as a base because it accepts proton. Remember, every acid has a conjugate base and every base has a conjugate acid. Practice makes perfect. So here are a few questions for you to try. So from question A to D, you need to identify the conjugate acid-base pairs for this equation. Are you ready? So let's do this together. When answering this question, I'm going to use abbreviation so that it's easier to see. So A is acid, Ca stands for conjugate acid, B stands for base, and Cb stands for conjugate base. So let's see question A. So let's focus on the reactant side first, which is on the left side. Both reactants have hydrogen in the formula. So how are we going to determine which is going to be the acid and which is going to be the base, right? Because both are possible to donate the proton. So now let's shift our attention to the right side. Okay, so by looking at this substance HCOO minus, okay, so it is the product from HCOOH. So can you spot the difference here? Right? Okay, so we can see that HCOOH, which is the reactant, losing or donate its proton to form HCOO minus. So that makes HCOOH as an acid. How about its product? Its product is going to be the conjugate base. Remember, every acid has its conjugate base. Since HCOOH is the acid, so H2O will be the base. Therefore, H2O will accept proton, forming H2O+. H2O+ is the conjugate acid. Next, move on to question B. Focus on the left side first. On the reactant, we can see that H2O. Okay, clearly, only one reactant got H, so it has the possibility to be the proton donor. Therefore, H2O will donate its proton to form OH minus. Therefore, H2O will be the acid and OH minus will be the conjugate base. Therefore, F minus will be the base and accept proton to form HF, which is the conjugate acid. Are you okay? Right? Next, question C. Okay, focus on the left side. Okay, we have one of the species has hydrogen in its formula. Therefore, it will be the acid because it's going to donate its proton, and the product will be its conjugate base. CO3 2 minus will be the base and accept proton to form HCO3 minus, which is the conjugate acid pair. Next, we have H2O on the left side and also SO3 2 minus, okay, on the left side, which is the reactant side. So again, we can clearly classify H2O as the acid because H2O consists of hydrogen in its formula and it is able to donate its proton. Therefore, H2O will be the acid and its product will be the conjugate base. Meanwhile, leaving SO3 2 minus as the base, where it's going to accept proton forming HSO3 minus, which is the conjugate acid. Right?